right? So again, these are the major production categories, systems that are being utilized around the world. Right now, when it comes to Trinidad and the wider Caribbean, we have two major types of systems again, right? Which is the tank culture, culture in tanks, which could be intensive or semi-intensive, right? And pond culture, which is basically an extensive type of system. Right now, when you look at the globally, internationally, right? When you're looking at places like some of the major producers around the world, China, for instance, they do a lot of pond culture, a lot of extensive aquaculture, right? But yet they are the largest producers in the entire world, even though they utilize a even though their primary system of production is an extensive type system, right? You know, you would kind of think that places or countries where you're doing tank culture, where you're getting a lot of where you're getting a high density of fish or aquatic species per unit volume would have the larger production, right? Even though China does a lot of intensive culture as well, they do pond culture, but they do it so extensively, meaning there's so much of it that is being done, right? That really what accounts for the large production that they have as compared to other persons around, like other countries around the world. So they just do pond culture, even though it's extensive, they just do it in such in such a large amount, like it's so much that there's still almost 80% of the world aquaculture production comes from China and the Asian countries. Yeah, right. So pond culture could also be adapted, right, to do cage culture. And this one is a prime example of innovation at its finest at a local farm here in Trinidad and Tobago. So this is at Ken Farms Limited, right? Located in Orange Grove. That's like when you're going up Trin City side, right? Like where Blue Water something is. So this farmer, what he did, basically Orange Grove had a pre-existing aquaculture facility that existed a couple decades ago, right? It was government run, and it was approximately 100 acres of production, right? So they did 100 acres in pond type culture. When Ken Farms got the lease on the property, what he did, he he renovated and he fixed back up all the ponds and stuff. But instead of going out there and stocking fishes extensively in a pond system, right? What he did, he built cages out of PVC and netting and basically retrofitted those cages, stocked them intensively, and placed them within the larger ponds. So he could have gotten intensive production, even though the larger system itself is an extensive type system, right? And it allows him now for easier harvest, easier stocking, better management protocols could be in place, etc., etc. Because you have a lot more control when you have fishes in defined cages, as you can see, right? So you see these multiple cages that running from like where you see these guys walking. So they were actually past students, right? So they were the year before last year, tropical aquaculture students. That's when I took them to a field trip, right? So on either side was just production, and you could stock fishes at different sizes, etc. So you could have production coming along at different months and different stages. So it allows a lot of flexibility. When we're looking at tank culture now, there are two major methods or two major types that is done locally, right? One is clear water aquaculture and the other is green water aquaculture. Simply, the difference is with clear water aquaculture, we basically, in most instances, that type of aquaculture is done in an enclosed environment, meaning it's like under a shed, etc., that is protected from sunlight, right? Which maintains the water being clear, and we could basically stock heavily within a system like that, right? With green water aquaculture, we leave the system open to the environment. When you leave it open to the environment and the fishes produce waste, etc., right, it enriches the water, like what we would have mentioned before, right? But because it's exposed to sunlight, right, we get algae blooming within that system, and the water becomes green. So that's the reason why the water gets green, because of algal bloom. Right now, aquaculture farmers can either go the clear water route or the green water route. So basically, with green water aquaculture, we have a little bit more management with respect to that type of system, in terms of, if the water gets too green, right, then it could be a problem for the fish, right? If it doesn't get sufficiently green, it could also be a problem, because those systems are designed in such a way that when the algae blooms within the system, it would utilize and remove all the waste, etc. Right? So with that being in mind, the types of filtration, etc., that is put into a green water system is not as much as you would have with a clear water system. So if you do maintain that green water to the sufficient density, etc., in terms of how much algae you have within the system, you could get problems, right? With a clear water system, on the other hand, right, up front, you need to design your filtration components in terms of your mechanical filters to remove the solids, the biological filters, etc., to sufficiently be able to handle the waste and remove the waste from the system for the amount of fish you're going to stock. Yeah. So hand on hand, a green water system is less costly to set up in the initial phase, because you don't go as elaborate on the filtration mechanisms, etc. Right? You benefit from the fact that the algae will remove the waste from the system. Also, the algae also acts as a food source if you're doing tilapia, because tilapia eats algae because they're microherbivorous. So they actually feed off of algae as a food source. So you can actually feed a little bit less with a green water system. Okay? With a clear water system, on the other hand, you need to feed the fish a complete diet, right? Meaning the food that you feed any fish needs to be complete with all the vitamins, the minerals, the different requirements of the fish. In addition to that, everything that the fish eats within a clear water system is what you give it, meaning there's no other source of food, right? So if you do give it anything to eat, the fish will basically have nothing to feed on. With a green water system, right, even though you don't feed the fish, right, which you should, but even though you don't feed it, they can still feed to a certain extent off of the algae, yeah, as part of the diet. So you do what we call supplemental feeding with a green water system. Yeah. Now, because you have algae, etc., within a green water system, right? You can't stock as high of a density of fish as you would be able to stock with a clear water system. So you get stock back. So the stocking density in a green water system is slightly lower than a clear water system. So these are some of the advantages, disadvantages. When you look at aquaponics now, right, which we would cover in another lecture later down, right, which is the combination of aquaculture and hydroponics, and you're cultivating plants now within that system. You could only utilize a clear water aquaculture system in an aquaponics system. You cannot utilize a green water system. A lot of persons would have tried to do that before, and they would have encountered them problems, simply because the algae within a green water system is a plant, right, that feeds off of nutrients that the fishes produce. In aquaponics, we need 100% of the nutrients that the fish produce. So with a green water system, you basically, it's like you're cultivating weeds within your system. It will not be applicable to, it basically will not work for growing out your plants, because they wouldn't get the sufficient quantities and nutrients they're looking for, right? In addition to that, the algae could get on the plant roots, etc., and cause further problems. With a clear water system, however, basically all the waste that is produced and converted within the system is made available to the plant. So that is why in aquaponics, especially with aquaponics, we need to cover those fish tanks and make sure the water always clear 100% of the times. Yeah. So Apart from clear water versus green water, tank systems could also be flow through or recirculating, right? So as the name suggests, let me look at flow through. Flow through meaning if you have a tank setup, and let me say for instance, you are living by a spring, a natural source of water that basically you have water being generated and flowing naturally 24/7. Yeah. So if you have that source of water, right, and you have clean, fresh water flowing naturally 24 hours a day, right, what you could do, you can set up what we call a flow through system. So you can set up your tanks and you can have, or you can divert that water that's coming out of that spring, for instance, or basically any other source of clean, pristine water. You could even have streams and stuff like that as well, right, with nice, clean, fresh water. And you can have that water enter the tank on one end and exit the tank on another end. So that is basically the water entering at one point, taking up all the metabolites, all the waste that the fishes produce. And when it exits and leaves the systems and goes back out into the environment, it takes with it all the waste of the system, the fish produce within the system. So the water quality will remain 100% intact all the time because the water basically flows through the system. There's no need to have a filtration component, mechanical filters to remove the solid waste. There's no need to have a biological filter to convert the ammonia that the fishes produce, etc., because it doesn't remain within the system. It enters, and it exits, and when it exits, it removes all those contaminants, and the water quality remains 100% all the time. Yeah. Now, flow-through systems very rare to non-existent within Trinidad and Tobago because the fact that we simply don't have that kind of access to clean, fresh flowing water. Even if you go to try to use normal river water, you're going to end up in real problems because the fact is most of our waterways are heavily polluted and contaminated. So it will not work well for flow-through systems. However, what we capitalize on a lot here is recirculating type systems. Yeah, same tank. The difference is we use an initial batch of water. So like let me say we set up a system, we fill our tanks with water. Now the water there's no water entering or exiting that system. Basically the system does what we call recirculate. So with a recirculating type aquaculture system, we had a fish tank and there are several other components now that would basically filter and purify the water and basically recirculate or send it back into the fish tank. So it is reused, 100% reused all the time. This is what a recirculating system is. The water goes through some filtration component that helps increase and bring back the water quality to the optimum standards and conditions. And then the water is sent back into the tanks and is continuously recirculated from tank to filters to tank. Yeah, all the time. And that is what a recirculating type system is. And when we go a little further, we will go in depth, a little bit more in depth into the different components of a recirculating system, right? So you got to understand exactly how a system is designed, how it's laid out, and the importance and the functions of each component in keeping that water clear and clean for the fish. Again, when I say fish, it also refers to shellfish like crayfish and prawns and stuff. Eh? So this is an example of a commercial green water tank culture system here in Trinidad and Tobago, right? I believe I would have mentioned or shared this with you all before. So this particular farmer, he does each one of those tanks again, just to recap, does approximately 1,000 pounds of fish, and he has 198 on his facility. Yeah. So this is the level of production, and this is local, this is in Trinidad. Yeah, so we do have a lot of aquaculture production going on here as well, a significant amount, but there's still the majority of the like tilapia, for instance, the majority of tilapia that is consumed is still imported. We're still not producing that quantity as yet. right? So again, this is a closer photo of what or a video of what the green water system is like. So remember, I told you all that you want sufficient quantities of algae within the system to keep the water qualities, etc., in check and in balance, right? So this is the kind of, so this basically is the aeration device within the green water system, and it gives a good idea um on the density, on the color of what the water would actually look like. Yeah, so you see, it gives you a better idea now, the video on how green the water really is. Yeah. So I mean, when you're looking at the water just now, it wasn't really looking green. It kind of looking kind of black, you know, that's or dark green. But really, when the water bubbles, you can really see it's a light green sheen. But it's just the volume of water making it look dark. Yeah. Another thing to take note of as well, with our green water system, we don't need to use we don't need to heavily aerate during the day, right? Because of the fact that the algae within the system, right, or the plankton within the system also produce oxygen as well, because they are microscopic plants and they photosynthesize, right? They produce and release oxygen into the system. So you don't need as much aeration as with a clear water system. However, at nighttime, you need to add supplemental aeration. Some farmers don't add aeration during the day because they get sufficient from the algae. But at nighttime, you do need to add aeration because there's no photosynthesis taking place at nighttime. The algae does not produce oxygen, but at nighttime, it continuously respires as well, and it utilizes oxygen. So there's no source of oxygen for the fish. And in addition to that, the algae is taking additional oxygen as well too. So you definitely need to add supplemental or aeration at nighttime with a green water system. Yeah, so that's just something to note as well. So this one are the challenges with a green water system, right? So you notice the color I shared here, like you're seeing here in this video that I shared, right? It's nice, a kind of nice sheen, a nice light green sheen, right? That is actually what we strive to accomplish, or strive to achieve with our green water, to get in the water to that density, the algae to that density. What happens if it gets too dense, right? Remember, I mentioned to you all, if wastewater from an aquaculture facility goes into rivers and streams, it could cause what we call eutrophication, meaning the algae would bloom within the streams. It will get to such a high density that it could eventually die, and the algae will die off, and it strips the system of oxygen and etc., and it kills all aquatic species and all aquatic life, right? So basically, that could also happen within a green water aquaculture system. So remember, I told you that it takes a little bit more maintenance, right? Maintaining that green water and making sure it's at the optimum density with algae, etc. So this is what happens. This is what happens when it is the algae builds up and into a too high density, right? It eventually dies. And when it dies, right, it strips the system of dissolved oxygen, and it can get mass mortalities within your system. So you have to be very careful, right? So in contrast to the last video I shared, right, I want you to have a look now on what the water would look like when the algae dies. Yeah, so it is basically brown water because everything died within the system, and it's a type of environment now where we wouldn't have we have very limited dissolved oxygen there, and the fish will suffer from a lack of dissolved oxygen. Right, so recirculating aquaculture systems, key features and traits. Recirculating systems are mechanically sophisticated and biologically complex. Fish are usually reared intensively, 0.5 pounds per gallon or greater, right? and it's reared in that high density in order for recirculating systems to be cost effective. Because they had to realize, from the time you start to set up a recirculating system is an investment, is capital intensive in terms of the fact that you had to buy a fish tank, you have to buy equipment to set up a mechanical filter, equipment to set up a biological filter, aeration devices, air pumps, water pumps, plumbing fit, so all of these different things comes at a cost. So you don't want to be spending excessive amount of money investing into a system with very low returns. Yeah, so how you compensate for that with with a recirculating type system, you have to make sure that your stocking density is intensive, right? So that you get a large output for that investment that you're making. Yeah? Right? So some other key features and traits of a recirculating type system: the operation water is reused after cleaning and filtering process, right? So you have your mechanical and your biological filter, which helps achieve this. Yeah, so your mechanical filter removes all the solid waste that the fish produce, and all the liquid waste in the form of ammonia, etc., is removed by a biological filtration. Recirculating systems considerably increases productivity per unit of land because it is an intensive way of farming, right? It's the most efficient water-saving technology in fish farming. It is suited for intensive production, and there's a great amount of site selection flexibility with our recirculating systems. Because they're growing in tanks, you can basically pour them tanks anyway once the surface is flat. Yeah. So even though you have a pre-existing concrete building, a concrete structure, dirt floor, it don't really matter. You could set up your system. So there's a lot of flexibility, site selection flexibility. If you was doing pond culture, where you had to dig a earthen pond in the ground, now you had to be extremely targeted to where it is you could do that. You just can't go on any piece of any type of soil and do it. You had to be a specific type of soil, the elevation of the land needs to be flat. All there's many requirements that needs to be met to be able to set up a pond type system. Yeah, so the site selection for that is not flexible. It's very specific. And again, with recirculating type aquaculture systems, control of water quality parameters is a key feature because of the fact that you could do adjustments, etc., very easily to these types of systems. So there are many advantages and some disadvantages as well to a recirculating type aquaculture system. Because you are reusing the water through a water treatment process, there's a reduced there's a reduced requirement for water, because up to almost, in some instances, 99%, you use 99% less water than conventional aquaculture systems, because they're basically recycling the water all the time. Yeah. You have year-round production. Now, year-round production is more like if you go to temperate countries, for instance, like in the US, right? If you're doing pond culture, you can't really do year-round production with pond culture in the US because the ponds will basically freeze over at that time, right? Now, with recirculating type tank culture systems, we could do them indoors, under heating, etc., etc. And we could basically cultivate fish year-round. Yeah? You could use existing buildings. There's a very high yield per gallon. It allows for a high degree of environmental control because we have because the because the fishes are grown in tanks, right? Environmental controls are very easy to control. With ponds, it's very difficult, right? We have improved feed conversions as well. Some of the disadvantages is a high initial investment, right? It's a complex system. You have to understand all the different water quality parameters, right? pH, temperature, salinity, ammonia, nitrites, nitrates. Now we will cover all of this when we do water quality, right? So all of these things play a factor in production, it impacts the fish either positively or negatively, right? When you have a recirculating type aquaculture system, you want to be able now to maintain and keep all these parameters within the optimum range for the fish, right? So it is a fairly complex system, But again, once we go through all the different components and we go through the different water quality parameters, etc., you will get a better feel of how simple it is, how easy it is. You can maintain good water quality, etc. for you. Yeah. One of the other disadvantages with a recirculating aquaculture system is that you have expensive equipment, right? In terms of the pumps and the air blowers, etc., the air pumps, right? There's a lot more water quality management that needs to be you need to do with recirculating type systems, right? If you have inefficiencies in your filtration, both your mechanical and your biological, you could get mass mortalities. Your fish can die, right? And it's a fairly difficult to get loans locally for recirculating type systems, right? I mean, that will kind of be, we kind of ease, things becoming a little easier with respect to that, but there was a lot of failure before with persons setting up recirculating type aquaculture systems, right? And not succeeding with it, right? And the reason being, again, after you will finish, or we go a little further along into the course, you will see all the different aspects of a recirculating type system. And having no training and diving into recirculating systems, it is like running into a brick wall in most instances, because if you really do understand what all the different processes, all the different equipment, the rules, the functions, how to properly set up and design and manage a system, you could get a high degree of failure, right? However, after this course, you all would see for yourself how well equipped you could be now to go there and manage a system. Yeah. Somebody asking a question. Okay, Jared. Yeah, I did send it to everybody, but I think yeah, probably something went wrong there. I will. Thanks. Yeah. Right. So these are some of the major components of a recirculating type aquaculture system. Right. Your fish tank for fish growth, your mechanical filter which removes the solids waste, your biological filter which converts the liquid waste into a form that is not harmful to the fish. Right. So basically it facilitates ammonia conversion. You have an aeration system which adds oxygen, right, which is critical for all the organisms within your system, meaning your fish and your beneficial bacteria, and a pump system which allows the water to flow or recirculate throughout all the components. So those are the five major components within our recirculating aquaculture systems. Know what they are, know their functions, right? This is very important, right? And this is a general layout of these major components here. So we have, let me start with the fish tank. So we have a fish tank here, and we basically stock it out with all the fish, and we culture we fish in here until from fingerlings, from a small stage to a large stage where we will harvest and put out into the market, right? So basically, this little pipe you see and this little white pipe you see in the middle here, this just facilitates the water to flow out with the solid waste. Yeah. So in this fish tank, we had the fish, we culture any fish in here. The solid waste, the liquid waste, etc., flows out of this component and it enters the first filter, which is the mechanical filter. And the mechanical filter is responsible for solids removal. So all the solid waste that exits the fish tank goes into the mechanical filter, right? And because of the design of the mechanical filter, it basically traps and removes the solid waste. Yeah. No, we will get into some designs a little later down. But the mechanical filter traps and removes solid waste. But remember, the fish produces ammonia, which is also a waste product, but it's a liquid form of waste. So it cannot be trapped within a mechanical filter. So biologically, we convert this ammonia to a form that is not harmful to fish, right? So basically, fish produce ammonia through the gills and through something called nitrification, or the ammonia conversion process, right? It is converted to a less harmful form. So basically, it is converted from ammonia to a form called nitrites, and then the nitrites is converted into something called nitrates. And the nitrates is the least harmful form or the least toxic form of ammonia, right? So it don't really impact or negatively affect the fish unless it's in extremely high quantities. Yeah. So in your biological filter is basically where your ammonia is converted to nitrates. So you convert from ammonia to nitrates to nitrates. After that conversion process is completed, the water is now pumped back into your fish tank. Yeah, and it completes the loop. So the fish tank, you culture a fish, they produce waste in there, it goes to mechanical filter, the solid waste is removed, the liquid waste continuously moves through the system, it enters the biological filter. The liquid waste is converted and now clean water, quote unquote, is now pumped back into a fish tank. And that basically is the recirculating type, it's a recirculating type system. So hence the name recirculating aquaculture systems. Yeah. Any questions on that?
You said it's nitrites to nitrates or nitrates to nitrites?
Nitrites to nitrates.
Thanks.
Nitrates is the end product. And bear that in mind because in aquaponics, all right, now it would say exactly how this aquaculture system will now fit into aquaponics. Because with aquaponics, we have exactly what you see in here is what we have with aquaponics. The only difference now, when the water leaves your biological filter and it's already converted and you have all the nitrates and it flows back to your fish tanks, in between your biological filter and your fish tank is where you put your plant grow bed or your plant grow out system or your hydroponic component, right? Because nitrates is the form of ammonia that plants readily utilize for growth and development. They use an extremely small quantity of ammonia only, right? So they don't use solid waste. In aquaponics, they don't use solid waste for your plants. You use liquid waste, but is really the nitrates, is that form of liquid waste that you utilize. So this is why aquaponics further extends the use of your water. Because when the nitrates keep building up and it goes back to your fish, yeah, it's not really harmful to your fish. But it over the course of time, like over time, it will build up in concentration. And then it will start, it could pose a problem to a fish now. So at that point, we do a partial water change. We change out some of the water and we refill it back with fresh water. With aquaponics, because you have a plant component now before it reaches back into the fish tank, that plant component filters out all the nitrates and they utilize that for growth and development. And now clean water goes back into the fish tank. When I mean clean water, I mean water that is free of all the different components within it, meaning like the nitrites, the nitrates, etc. Right? So this is how aquaponics further extends the use of your water and you get a byproduct in terms of the plants because this at a level, when the water leaves this biological filter here is the nitrates, right, is really high in is really a very good source of plant nutrients. Yeah, naturally produced or quote unquote organically produced nutrients. Yeah. Right? So the first component of a recirculating aquaculture system we're going to cover is the fish tank, right? And again, the fish tank could be different sizes, it could be different dimensions, different shapes. Some shapes are preferred over others. Some types of materials that we utilize to build the tanks are preferred over others, right? So your fish tank, which is used for your fish growth. So these two photos are actually local tanks. These two different systems I set up for two different clients of mine, right? It's the same size of tank, just come in different colors, and both are recirculating type systems with a very high um, production capacity. So again, each one of those tanks doing easily 1,000 pounds of fish, right? So aquaculture tanks, the tank material, it could either be made out of fiberglass, inert plastic, concrete, or plastic lined. Yeah, so fiberglass, inert plastic. When we say inert, we do just want to use any plastic material because there's something called plasticizers, right? Which is basically if you do use like food grade plastic, etc., when you when you utilize these, it actually leaches a chemical out into the water and it's not good because the fish get accumulated within the system. Yeah, so you want to use inert plastic, something that will not really leach or release anything into the water. Yeah. plastic lined ponds become, or what we call quick tanks, right, are becoming very popular, right? So basically these fish ponds, they actually have a framework, a wire mesh framework that folds and packages neatly into a box. And then you have the skin or the liner for it, fold and packed neatly into a box as well. And it's a very nice package, small unit, and you can purchase this and basically just like it's like a swimming pool, basically, quote unquote. It's literally like one of those pop-up swimming pools, and you can pop it up, but it's really a fish pond. Yeah, because the material, everything designed and made to keep fish. And then the other popular material that we utilize to build tanks is concrete. And I mean, most persons who would have done small scale ornamental productions back in the day would have a lot of them would have utilized concrete ponds and stuff, and they still utilize in aquaculture as well too. But in terms of convenience, ease to move around, etc., a lot of persons opt for purchasing the bigger fish tanks so they can move it around and etc. Right? So fiberglass and inert plastic are recommended, right? For major reasons: durability, long lifespan, convenient to install, fairly lightweight and maneuverable, right? So again, with aquaculture tanks, several important aspects to consider. One, the material must be non-toxic, and as well as it must be durable, right? When it comes to tank shapes, there are different types of shapes, right? Circular, rectangular, and square are the most common, and there are advantages and disadvantages to shapes, right? One, a tank shape greatly affects water circulation, right? Now, for that reason, circular tanks are preferred because of its self-cleaning properties. Now, think about if you are a circular tank, right? Now, let me see. I don't know if you will ever just drink coffee and thing, right? But if you take a cup and like if you have like the dregs from the coffee or basically any solids to the bottom of like a cup, you could probably try this after a nice cylindrical cup. Take your finger, put it in, and turn it in either a clockwise or anti-clockwise motion. And what you would have happening now, right? You would start to get the velocity of the water moving in a circular pattern around the circumference of a circular type tank, or in this instance, inside of your cup. And when you get a circular flow taking place, what happens is that the current would basically um, it would basically increase from outside to in. You will get difference in current from the out from the tank wall or the cup wall to the inside. And when that happens, it basically takes all the solids in the bottom and settles it at a point directly in the middle, either the cup or the tank, right? So once that water comes at an angle and it moves at an angle around the circumference at a 45-degree angle, whether you point your finger and you turn it, or the water is injected or returned at an angle, a 45-degree angle, it starts to generate a circular flow around the walls of the tanks, and it settles all the solids to the middle. And because of this reason, circular tanks are preferred because it's the most efficient when it comes to um, collecting and removing your solids. Because at that point now, you can put your solids removal mechanism to be able to remove all the solids, because it's basically handy, it is basically delivered to that one point, and then it just exits off of the system. Imagine you had one of these tanks to the bottom right, one of these kind of, I don't know what shape to call it, irregular shape, right? And you have fish within here producing waste, right? Think how difficult it would be to get a proper stream or current within here to gather all the solids. It's impossible to gather the solids. The solids will settle in this corner here, settle that corner to this corner, down to the bottom right, all over the place. And the solids will remain here. And even though it don't matter where you put your solids removal mechanism, it will not remove all the solids from the system. The solids will build up, it will deplete your water quality conditions, it will foul your water, you can get mortalities, the fish won't grow as well, a lot of problems. With a circular tank, you will get all the solids settling into the middle, you can tap it off. With a square tank and a rectangular tank, it's still fairly easy to remove your solids, right? But with these irregular tanks, definitely no. Okay. One of the square tanks that is more common for, especially for small scale hobbyist producers, is these IBC or these two tanks. That's the tanks at the bottom left, right? Those are kind of more square, right? They're very popular in Trinidad, throughout the Caribbean, and think because they're cheap and people use them for fish tanks, and those will work fine as well. It's not as good as a circular tank, but it works. It works good. The ones to the right, definitely no. Right? So avoid tanks again with non-geometric shapes. So culture tank design, it must maximize the capability of the tank system for self-cleaning. Right now, the dominant reason why, well, RAS stands for recirculating aquaculture systems, which is what we talk, which is the tank systems we're talking about. So the dominant reason why RAS fail is due to the inability to self-clean, right? Meaning, if you have a recirculating type aquaculture system and you need to remove the solids out from the system through a mechanical filter, and then you get liquid waste converted in a biological filter, etc. If your system is designed in such a way or using materials or tank shapes and you are unable to remove that solid waste, it will build up over time and the entire system will shut down. Yeah. Right? So again, circular tanks best suited, especially for commercial systems, because again, the fact that it can settle all the waste within the center of the tank and it can be tapped out. Look at the photo to the right. You notice you see the red arrows. So that's showing you the water coming in at an angle and it creating the circular pattern. If you notice in the middle, you're something like a little vortex. Think about like a tornado as well too, because that works in a kind of vortex manner. Yeah, so you notice it kind of moves in a circular way. So this is how a circular tank really trumps all other designs for a tank for a culture system in aquaculture, right? So if you see here, you notice it's in a little vortex, and to the bottom is in a dark circle. So that's basically where these people would have put their drain off, because this vortex would have driven all the solid waste to the middle and it would have been tapped off. Yeah. So again, that's one of the reasons why circular tanks again is preferred. So filtration. Mama told you it have two primary types, a mechanical and a biological. So the first type removes all the solid waste from the system. Solid waste is primarily produced by uneaten feed, right? And fish waste, the feces. So you want to get that out, right? Solid waste accumulation blocks, it causes blockages in pumps, plumbing, etc., etc., right? Unfiltered waste creates anaerobic spots, meaning areas where it actually because of its decomposition, right? When waste remain in the system and it decomposes, right, it actually utilizes oxygen and strips oxygen from the system. So that particular area would be anaerobic, meaning it wouldn't have any source of dissolved oxygen. And again, that's a prime requirement for aquaculture species, dissolve oxygen. So if you do have any, you can get mortalities and stuff taking place, as well as stressing the fish out. So mechanical filtration. So solid waste that the fish produce, right? It actually could be classified into three categories: settlable, suspended, and fine and dissolved. Right? So fine and dissolved is kind of one and the same. Right? So these three solid types, right? So when the fish produce solid waste, it can be categorized into either one of these three categories based on the physical nature of the waste itself. Yeah. So as the name says, basically implies, settlable waste is really the larger, more chunky waste that the fish produce. So basically, when the fish produce the waste, it drops to the bottom. It settles, right? However, you could also have suspended waste that the fish produce as well, right? Suspended suspended solids basically, um, is finer solid waste, right? So it's fine, and it fish waste is more or less be almost neutrally buoyant, meaning it's not really a very heavy type of waste. Yeah, it's not really a heavy type of waste like you will get with other types of animals, right? So that's why this kind of see fish waste for whoever mind ornamental species and thing. You get see fish waste kind of floating through the system. Yeah, so it's kind of neutrally buoyant. So yeah, sorry about that. Right, so kind of neutrally buoyant, etc. So apart from the ones that settle to the bottom of the tank, the suspended ones are finer particles, and because they're already so light, they don't readily settle to the bottom of your tank. They kind of just remain within the water column, floating around. Yeah, remain within the water column, floating around. Hence the reason why they call it suspended, because it just kind of remains suspended within the water. It takes a certain period of time for it to actually settle out and drop to the bottom, right? It's like dust within the air. You know, you kind of see dust, like Sahara dust. You know, Sahara dust kind of coming into Trinidad and thing. So you have dust particles that more or less suspended within the air column, right? So suspended waste is kind of suspended within the water column. Fine and dissolved solids is basically the parts of the solids that actually dissolves within the water, and that just kind of remains within the water. It's very difficult to remove, but it's not a big issue with aquaculture production. It doesn't really cause much problems for fish. Yeah. So settleable solids is the easiest of the four categories of waste to deal with. It should be removed from the system as quickly as possible, right? It settles out of the water within 1 hour under still conditions. So this is actually what gives it its designation as a settleable solid. It's a solid particle, right, that settles within 1 hour under still conditions. If it doesn't settle within 1 hour, then it is going to be classed as a suspended solid, right? And it is removed from culture systems via outflow mechanisms, etc. So this is what settleable solids look like. The reason why it's floating to the surface is the fact that it's settled to the bottom. But remember, I told you all, if you have solids remaining within the system, when it starts to break down and decompose, right, you get bacteria and stuff like that building up within the system, and it strips oxygen, right? What it also does, sorry, is release different types of gases, etc. by the decomposition process. These are natural process. And when it releases gas, what happens? It becomes even lighter, and guess what? It floats back up to the surface. So this is what happens when you have suspended solids, settleable solids within your system, and you don't remove it. It starts to decompose, it starts to break down, and then it will rise back up within your system. And trust me, that going to cause real plenty problems. So you really need to remove your settleable solids as soon as it's produced. The other type I told you all about is the suspended solids, right? And suspended solids will not settle out of the water column under still conditions within 1 hour, right? It could significantly limit the amount of fish that can be grown within the system, because if you have plenty suspended solids, what would happen? It will go on to it will go on to and irritate your fish gills, all these different, it will cause a lot of problems, right? It is removed by mechanical filters using screen or media to trap the particles. So in your mechanical filter, while you have mechanisms to remove all the heavy stuff that will settle to the bottom, you also have a lot of mechanical filters also have netting mesh within the filters, right? So it traps any suspended solids that flowing through that water. When they come in contact with the netting, it will trap it and it will keep it within the filter so you can be able to remove it. And the third type of solid waste is the fine and dissolved solids, right? So these cannot be easily removed by conventional mechanical filters because they're so fine, right? They will not settle within the filter and they will not be trapped by the screen or the netting or whatever you put in to trap those solids. Yeah. Fine and dissolved solids doesn't pose a significant problem in systems, right? So in marine type aquariums, there's a component called a a foam fractionator or a protein skimmer. You would hear this term very common with persons who doing marine type aquariums, etc. Protein skimmer, right? So in marine systems, they really want to remove all the different types of solids, and these are aquariums. So they use something called a protein skimmer, and this is a device that they could use to remove fine and dissolved solids, but it's not necessary in a normal aquaculture system. Right? So these are examples of popular mechanical filters, right? So the first type is a baffle clarifier. So how this works is that you see where the arrow enter in here, right? So the arrow coming from this direction. So this is actually water that leaves the fish tank with the solids, and then it enters into the mechanical filter. In this case, we're using a baffle clarifier. Baffle simply meaning there's a partition in the middle of the filter, right? So the partition goes down almost 3/4 way down within the filter, right? And to the bottom of the filter is shaped like a cone. So what happens now? When your water come in here now, right? It enters into the filter with the solid waste. Right now, ideally, the it should enter at facing at a 45-degree angle up, right? Now, when it enters, the velocity of the water pushes the solid waste to hit against the baffle, right, or the partition. And what happens when it hits this? It basically it goes under some turbulence, right, and it causes it to kind of spin, and then guess what? Drop to the bottom here and settle out because it hits the baffle, and then it falls to the bottom and settles within the cone. And in the bottom of the cone, there's usually a tap off, a drain off. So ever so often, the aquaculture farmer will come now and turn that valve, and all the solids will exit the system. Yeah. So basically now, when this baffle clarifier, the water with the solid waste will hit the baffle, it will drop to the bottom, the solids will settle in the cone, and the clean water now, well, the water with all the solids now will go on the bottom here now, because remember I told you there's 3/4 way down, right? So the space between the bottom of the baffle and the cone is where the water will pass now, free of heavy solids, so settleable solids, and it will now rise up now. Sometimes they have a secondary baffle, right? And behind that baffle, you could put screening material like netting or meshing or anything like that. So even though you do get the suspended solids now, because remember they're not heavy, right? So even though it hits the baffle, it still wouldn't settle out, it will remain suspended. So the heavy solids, the settleable solids will settle out, tap off. The fine, the suspended solids now will pass underneath here, come up, be trapped within the second baffle, right? So wherever you mess with the first one, it can be trapped with the second one. But even so, the water still has to flow under the second baffle and come back up. And it's in here you keep pollinating. So whatever fine whatever settleable suspended solids you have within the water will now be filtered out now in the screening. And clean water now will go into your biological filter. You must have your water being filtered before it enters into the biological filter. A biological filter is where you have your beneficial bacteria, right? Which converts the ammonia into the nitrates. And this bacteria must not, to basically have this conversion taking place, you had to make sure that you don't have any kind of solid waste and stuff inside of there, because they're going to reduce the efficiency of how the waste is converted. So you want to make sure that your waste, your solid waste, is filtered out before it enters into a mechanical filter, a biological filter. And this is basically one type of a mechanical filter. The second type of mechanical filter you have is a swirl separator. Yeah, that's two of the more common types. So the baffle one, you have a baffle down the middle. It hits the baffle, it settles out, or so you know the mechanism how that works. With your swirl separator now, you have the water enter in, right? Somewhere around 1/3, depends. Some people have different designs for it. So usually you have the water entering at one third from the bottom up into right into your filter. So in this instance, this is a simple swill separator made from a barrel, right? It made from a 55-gallon drum. So basically, this is the water that coming from your fish tank with all the solids, right? So you actually have it entering into your barrel, or what we call your swill separator. And then you have a elbow, a T, and you have the water exiting at 2 points, right? And you have it facing 45-degree angle to the walls of the barrels. So what happens now? I'll try to shoot a video with this for you all and share it in the next class. So you would actually see from a 3 dimension, you actually see it working, so you have a better idea what it is that we're trying to explain to you, right? But just imagine the water coming from a fish tank with all the solids, and the water going, it exiting at opposite ends to each other against the walls of the barrel or the walls of the filter. What happens there now is, because it exiting at opposite ends, it creates a swirling motion, like when you put in your finger inside the coffee cup and you turn it, like what I was explaining to you all, and you settle all the solids to the middle. So swirl is, you're really creating a swirl within that barrel, within that filter. And by the swirling motion, right, settles all the solids down to the middle, and it can easily be drained off. Yes, so you see all the fish solids settling to the middle and it can be drained off. And this is what a swirl separator does. And when all the solids here settle thing to the middle, clean water basically goes to either we grow beds if it's aquaponics, or goes back to we fish tanks. Yeah. Any questions on the filters? So good, everybody following, right? Nice. You could also make, I mean, you're not limited to your design of a filter, right? Your filtration components could be, there are many different types it could utilize as well, right? So those again were two are the most common. This is another type, a very simple type that I made from 2 buckets, right? And I use this on my koi ponds. Very simple, utilizing gravel. And as you can see, this is a clean filter to the left, right? And to the right, you could actually see the solid waste that it was able to trap and remove from the system, right? So again, the whole purpose of a mechanical filter is to be able to trap and remove the solid waste. Yeah, right. So this was my filters that I built with a very simple system. Set it up, fish tank, pump inside of here, pumping it up, it going here, filtering out. And the gravel within the system also performs some sort of biological filtration as well. So this filter basically does mechanical and biological filtration. And you know what? It's a very cheap alternative to what persons will go out there and buy for their koi ponds. Those koi filters and stuff that people go and spend $3,000 for, and $2,000, those canister filters are basically, um, how could I put it, commercially produced filters that basically performs just like this. And this cost me like $10, and some fitting like it $50 max, as compared to 2,000 and $3,000. So again, you know, really understanding the functions of these types of filters, etc. You know, you could build your own filters once you're achieving your objectives. Right. So that's that for mechanical filtration. Right, we're going to go into biological filtration. Right, so we just over our into class is 5:14. I'll just give everybody a quick 5-minute break, right, and then we will resume at 5:19. Let me just say 5:20. Yeah, so let's take a 5 minutes break, and at 5:20 we'll resume back. Yeah. Okay, good. So we're back. All right. So just confirm everyone here, right?
Yes, sir.
Okay, thanks. Right. So biological filtration. So any questions on the mechanical filters? Mechanical filtration. Okay, nice.
No, sir.
All right, nice. Right. Biological filtration. So basically, biological filtration or biological filter facilitates the conversion of ammonia or ammonia conversion, right? And this happens by the process of nitrification, right? So basically, fishes produce ammonia through the gills. So if you look at the bottom equation, right? So NH3 is ammonia, right? It is produced by the gills of the fish. And the first group of bacteria that is responsible for converting ammonia to nitrites, which is NO2 minus, right, is nitrosomonas. Yeah. So basically that is, so both nitrosomonas and nitrobacter, right, are two different groups of bacteria. Basically, they are both nitrifying bacteria, right? But they perform different functions, right? So the nitrosomonas bacteria convert the ammonia and into nitrites, and then the nitrobacter converts nitrites into nitrates. And again, both are nitrifying bacteria, and both require oxygen for this process to take place, right? So that is why it's important in a aquaculture system, right? If you set up a recirculating type aquaculture system and you have a biological filter in place, you need to add aeration to your biological filter. And this is where a lot of persons they fall short, because they just think that your fish alone need oxygen, but that's not true, right? Your bacteria within your system are aerobic bacteria, meaning they need air in order to be able to carry out their functions, yeah, and to survive. So basically, they need oxygen, so you need to aerate your biological filter. What you're seeing here, right, is basically the inflow from your um, the inflow or the outflow, either one of the two, from your mechanical filter. Oh, actually, this looking like the out. Yeah, sorry, is the inflow from your mechanical filter, and it enter in the biological filter. So through these little holes and thing here, your water will come out, right? Your water that is free of solid waste but high in ammonia, and then it goes into your biological filter. All your biological filter is nothing really special, right? In terms of let me say unique to the system, right? And so you want to wrap your mind around this idea. So a biological filter is basically a filter within your system, right? That really contains, right, the highest density of bacteria. So bacteria, nitrifying bacteria, nitrosomonas and nitrobacter, will colonize, or it will grow and adhere to any single surface within your entire aquaculture system that is in contact with water. So your tank surfaces, your plumbing, if you have a pump inside of the water, it will all have nitrifying bacteria in it. But what happens is, because this surface area is only so much, meaning it's very limited, because you have a large volume of water and the water only in contact with the circumference of your, like the inside walls of your tanks. So there's only so much bacteria that could grow onto those walls, and there's only so much ammonia that this amount of bacteria could convert, right? So a biological filter is just a empty tank within your system, right, that you fill with a whole set of small particles that wouldn't really that in it, and it wouldn't break down or dissolve, etc., within your system. So basically, like plastic beads, bottle caps, netting, anything that will increase or has a high surface area. So basically, you will get a lot of bacteria. Surface area increases the amount of bacteria that could colonize these particles. So if you look in this photo here, where you're seeing these white little things that looking like okra when you chop it up, is really biological media, right? Or biomedia, right? So the functions of these little media, you see these little white little cottons that you see inside of here. You see all the little faces that they will have on them, all the sides, the middle, you see, right? So on all those surfaces, you will get bacteria colonizing. So the amount of bacteria that going to colonize those small little particles going to be so much, right, that it could sufficiently convert all the ammonia that the fish produce to nitrates. And that's all a biological filter is. It's a containment vessel with media inside of it that increases the surface area so you could have a large amount of bacteria colonizing it. Because without it, right, you will still have bacteria on the sides of the walls, but it wouldn't be enough. So the little particles is increase the amount of bacteria that could form within that area. And in addition to that, when you set aside a biofilter, yes, you're setting it aside after the mechanical filter. So you know that only water with just ammonia alone will be present in there. No solid waste, because solid waste will not work out well for keeping your bacteria alive and functioning efficiently. So your biological filter really keeps the optimum conditions for bacteria, and it allows for a large concentration of bacteria. So in a biofilter, you basically have filtered water, meaning water that is free of solids, right? You also have water where you can add aeration to it. So you can actually put an airline and an air stone within your biological filter. So the bacteria now that on the surfaces of these little balls and all whatever you have, biomedia you have in there will get the oxygen that they need to convert the ammonia to nitrates. Yeah. So that's why it's a nice little special unit that you really keep for the purpose of culturing, right, and growing your bacteria. Just like your fish tank for growing out your fish, your biofilter is really where you want to keep the right conditions for your bacteria. And it's extremely important for aquaculture and even more so important for aquaponics. Because again, your biological filter is the key, right, to having a successful aquaponics operation as well. Because if you do have a functioning biofilter, what will happen? Your fish will produce ammonia, but your plants now will not feed off of this ammonia readily. They will feed off of nitrates. So you need to have your biological filter functioning efficiently. So it will produce the required amount of nitrates so your plants could utilize it for growth and development. Yeah? So it's important for both aquaculture as well as aquaponics. Right? So your biological filter or biofiltration facilitates the conversion of ammonia to nitrates. Bacteria are crucial for the process. Look at this little diagram I have here. So your fish produce ammonia, right? So the ammonia is produced in the waste, right? You have ammonia oxidizing bacteria, which is the same thing as nitrifying bacteria. It consumes the ammonia and converts it into nitrites. Nitrites convert into nitrates. And with aquaponics, Mama told you that you need the nitrates, right? The plants need to utilize nitrates. So in aquaponics, you need to have this process taking place so that the plants now could utilize nitrates for growth and development. If you do have your biofiltration working properly, your plants will show us some sign of deficiency, which will not grow. Yeah. Other than that, if you do have plants here, then the water will just what? Recirculate back to your fish. Right. So we talk
Can
about,
you run back the diagram, please?
sorry?
Can you just run back the last slide?
No problem. Right. So this is basically the process, right, in which the ammonia is converted to a form that is not harmful to the fish, meaning it will be converted into nitrates. Is also the process in which ammonia is converted to a form that the plants could utilize for growth and development. Right? So the fish produces ammonia through the gills, as well as some when it produces the feces and stuff, ammonia is produced there as well, right? But primarily through the gills. So this is a liquid. Ammonia is clear, colorless. So your water will look crystal clear, but it could be extremely high in ammonia, right? So that's like one of the things. A lot of persons, they will look at water and be like, "Oh, my water clean, like it good, like it clean." I was like, "No, the water is clear, but that doesn't mean it's free of any harmful chemicals or any pollutants or anything like that." So, anyways, so the fish produces ammonia, the waste is within the water, right? Your first group of bacteria, which is your nitrifying bacteria, your first group will convert this ammonia, right, into nitrites, right? So you see consume ammonia, NH3, and convert it to nitrites. So ammonia oxidizing bacteria is the same as your nitrifying bacteria, right? Basically what happens is oxidation of the ammonia, which is a chemical process. So that's why they call it ammonia oxidizing bacteria, but it's nitrification, right? So the fish produce ammonia is converted, the first set of bacteria converts it to nitrites, right? So the second set of bacteria converts the nitrites, they feed off of this and converts it to nitrates. Normally the nitrates now will be now pumped back to your fish because it's not really harmful to your fish unless it's in extremely high quantities. With aquaponics, right, this high nitrate water is pumped to the plants, and the plants utilize the nitrate for growth and development. And then the plants now remove the nitrates from the system, right, from the water, and then even cleaner water now goes back to the fish. Yeah. So without plants, the high nitrate water will go to the fish because it's the least harmful form of ammonia. Ammonia is extremely toxic to fish. Nitrites also very toxic to fish, but not so much so the nitrates. Yeah. So that is why we need to have this process taking place so that the water can be made safe for the fish. And if we have aquaponics, it can be used by the plants for growth and development. Yeah.
Okay, two more questions.
No problem.
How long does it take for a biological filter to be ready for operational use? And often, can you give the composition of nutrients in the nitrate?
All right. So the first question is how long?
Yeah.
Right. So we'll come to that just now. It usually take 4 to 6 weeks, right? Some literature will say 3 to 6 weeks, but anywhere between four, like a month and a half, for your biological filter to become fully established. Now, what happens when it is a set up a system, right? And you put your biological filter, you put everything in place, and you start that system, right? The system is free of bacteria. What happens is that bacteria will naturally colonize the system, right? Over a 4 to 6 week period, right? So within that period, you will get bacteria on the walls of your tanks, on the media, within your biofilter, etc. And over that 4 to 6 week period, it will build up in such high densities that it can sufficiently be able now to handle. Now that's provided you size the components appropriately, because you could have too less biological filter material and you wouldn't get the conversions you're looking for. But let me assume everything is sized the way it's supposed to size, meaning you put enough media to support the amount of waste produced by the fish, etc. And that in place, then within 4 to 6 weeks, it will build up to the full operational capacity to be able to handle all the waste and convert it for the convert the waste that the fish produce. Yeah. And the second question was the composition of nitrates. Now, when we get into aquaponics, we will go a little more in depth into plant nutrition. Right now, nitrates will work good for your vegetative growth, and in addition to that, you will get micronutrients as well too, but that will be from different parts of your solid waste, which we will talk a little bit more. Now nitrates is one of the biggest components that plants need for growth and development. When we do aquaponics, we will get into plant nutrition, right? And you would understand how the macronutrients are produced and what the plants need in the largest quantities, as well as the micronutrients. But I will explain, I don't want to get too much into that now. But when we move down into aquaponics, we will go more in depth into that. Yeah, but the plants do just use the nitrates alone for growth. is what they need in the largest quantities. So without it, the plants will show a significant reduction in growth, and in some cases it will be stunted, right? Once it gets it in large quantities, that's providing it also getting macronutrients from other parts of the solid waste in addition to uneaten feed. But we will get into that while we go along.
Thanks much.
No problem. Right, so biofiltration essential in aquaculture, ammonia, nitrate, toxic to fish, nitrates least harmful, right? Spoke about all this, right? So your biological filter material, your biofilter material, as the substances, the substrates you put within the filter to increase surface area, it needs to, so it's responsible, it increases the surface area for the colonization of nitrifying bacteria. It needs to have a high surface area to volume ratio, right? In it, easy to rinse. So these are some commercially available biofilter material. This is where you typically, traditionally go out and purchase, right? So the ones to the top here, the black and the blue, is what we call bio balls. They go under different names, right? Now, there's nothing special about this besides the fact that it has a lot of surface area in it. So you look at the black balls, right? You notice it have slits and faces all over this ball. So on every face, on the slits, you will get beneficial bacteria colonizing. So there will be a lot of bacteria on this. And this one is a set of spikes. And on all these spikes, you will get beneficial bacteria. Same thing with these rest of media. So all it does is really just increase surface area. So there are simple ones that we could use homemade if you want to call it, right? Biofilter material. First is gravel. Now gravel only has the external surface that you can use. Right, so the gravel only has the external surface that you could utilize for the colonization of bacteria. So it's really not the most efficient form of biofilter material, but at the same time, it's very cheap, right? And it's readily available. So if you don't have as much surface area, then you just need to use a little bit more to make up for that, right? But at the same time, it comes at a very low cost. So it's something that a lot of persons utilize, including myself, in a biofilter material, as a biofilter material, right? The other things they could utilize is bottle caps as well too, right? So simple, it could, and it helps with recycling, etc. And that works as a biofilter material also. Fish net, discarded fish net as well, you could wash it out, put it into your system, good biofilter material as well. Pot scrubs. So again, it just meets the criteria of high surface area to volume ratio in it, easy to rinse, and the function is to increase surface area for the colonization of bacteria. So you could use just about anything to perform the function of a biofilter material once it meets those criteria. Right, so a key point with biofiltration is the fact that it needs to be sufficiently aerated, because again, our mama told you all the bacteria is aerobic, it needs oxygen. So we had a question about this before. How long does it take before a biofilter becomes fully operational, right? And getting that process is called establishing the biofilter, right? So it's called cycling, right? So it's called, so basically when you start the cycling process, means you set up your recirculating aquaculture system, you plug on your pump and you start to get that water moving through your system, right? So that is the beginning of your cycling process, right? So this process starts after the system has been set up, and it allows the beneficial bacteria to build up within the system, right? So basically the cycling process could be, it could actually be expedited, right? Meaning instead of you waiting for your system to naturally be colonized with beneficial bacteria, and basically again multiplying and establishing over a 4 to 6 week period, you could actually go there now and purchase. They actually sell these beneficial bacteria, nitrifying bacteria, commercially. So you could go there and purchase this bacteria, and add it directly into your system, right? And it basically kickstart that whole establishment of the filter process. Yeah. So as opposed to you waiting 4 to 6 weeks, it could just take you a matter of days to really get your biofilter up and running. Another thing you could do besides purchasing your the beneficial bacteria and adding it into your system, if you have another aquaculture system and that biofilter is already established and is already functioning, you could take some biofilter material from there and inoculate it into your new system, right? So you could take some from there, kind of squeeze out some of the water and kind of put in that media together with the media that you know putting in a new system, and you can kind of kickstart and get the bacteria growing a lot faster because you already have a large source you're entering into you're putting into your system one time. So you can really get a system up and functioning a lot faster than if you wait for it to start from scratch, more or less. Right? So basically we have two main methods we use to get the biofilter or to get the biofiltration process up and running, right? So one, we could either use it, we could get it done naturally, right? Which I just mentioned. Well, obviously it will help if you have some fish within the system, right? Because the fish will be a source of food for your bacteria. If you cycle your system without fish, you plug on your system and you don't put any fish within your system, it will take a lot longer for that biofilter to establish itself. Because of the fact that, remember, the bacteria converts ammonia, the first group converts ammonia to nitrites, the second group converts nitrites to nitrates. But if there's no ammonia and there's no food source, right? How you think this first group of bacteria are really going to thrive and multiply within the system? It can't. It will establish a very small um, concentration, a very small amount, but nothing significant within any period, within any short period of time. If you have fish within the system and it produces ammonia, it gives the first group of bacteria food to feed on, and it multiplies and establishes itself a lot faster. And then when it feeds on that ammonia, it now produces a byproduct, which is the nitrites, for the next group of bacteria. And that next group of bacteria now could colonize and multiply a lot faster. So you really need to have a source of ammonia when you're setting up your biofilter, right? Because it really helps the bacteria to get food and to help along the process along. Yeah. So if you don't want to put in the fish and cycle the system, or if you want to get going a lot faster, then you could add what we call pond starter, right? Or what basically what this is just the beneficial nitrifying bacteria. It's called kickstarting because it kind of just getting the system up and running one time. Right? So again, our key thing is right. So that's that with respect again, yeah, biofilter up and running. Any questions on that so far? Okay, good. Yeah, question?
Nah, no question.
All right, no problem. Right. So the other thing we're going to talk about now that is important for a recirculating aquaculture system or a tank system is dissolved oxygen, right? So this will be you will generate dissolved oxygen through your aeration system. Yeah, so your air pumps, etc. So your dissolved oxygen is basically a process of adding dissolved oxygen into your system via aeration or oxygenation. So with aeration, you utilize atmospheric oxygen through blowers with air stones or aeration devices. Yeah. So like if you look at a aquarium, right? So I'm gonna see the next. Right. So you basically have like an air pump or air blower, and you have these aeration devices that releases bubbles within the water, right? That is aeration. because basically what that air pump will do is just take in atmospheric air, right, which has like 21% dissolved oxygen, and basically bubbling it through the system. Yeah. With oxygenation, we add in pure oxygen into the system, right? It's way more efficient, but it's extremely expensive. So it's only in specialized um, designs and growing very specialized or very high valued species would we even opt for using pure oxygen. Yeah, because it will super saturate that water with oxygen in it. Yes, like we'll use those oxygen tanks, like when you go and you see like on those like on TV, and like when you go and you get these medical masks put on you and you're breathing in pure oxygen, right? So you could actually put that into the system, so you could get a much higher amount of dissolved oxygen within the water column, right? So these are two primary ways that we basically add dissolved oxygen into the system. Aeration is by far the most common, and is the most common practice that we all utilize for adding dissolved oxygen within the system. Right, so this little video here is actually an air pump. So I did a small little video to show you exactly what an air pump. So these are air pump that I have here, and you would actually see how it will actually cause aeration within the system. Okay? For those of you who never saw like an air pump before or understand the mechanism of it. So these are 400-gallon tank. So it have air stones to the end of those lines, and you can see the kind of aeration that it gets. Yeah. So this is from an actual aquaculture tank, aquaculture system. I did this video, and this is for the fish itself, right? So basically the fish within this tank, and this particular aeration device was a disc diffuser. So it's like a 10-inch circular disc, and it basically allowed the pump now will send the air through that, and it will disperse a lot of millions of bubbles into the water. That increases the dissolved oxygen content of the water. Right? So you see how much bubbles being produced, right? So every time a bubble breaks to the surface of the water, dissolved oxygen is absorbed into the water column. Yeah. So all those fine little bubbles you see coming out, every time these bubbles produce and they break at the surface, right? It increases surface area and oxygen is absorbed within the system. So the fish always have dissolved oxygen for growth and development. Right? So aeration equipment, things like air stones, air disc diffusers. So that right, so the first video that you saw in the tank, I was using these little blue stones to the left here. And the system that you just saw there with the disc diffusers, these are what the disc diffusers are. These are what the disc diffusers are, right? So the disc diffusers are the devices that actually allows the air to basically disperse out into the water column. Yeah, so they will take a stream of air that comes from the air pump, and they have very fine pores within the surface, right? And through these fine pores, it disperses that air into small bubbles, right? So that's what air stones, air diffusers does, right? And then those things are usually powered by air pumps and air blowers, and this is an air blower. The difference is the size and the, right? So basically, if you have a big facility, right, and you want to power real big aeration devices, you want to get something like an air blower because it gives large, high volumes of air. Yeah. And then again, what we have again in our recirculating system are things like water pumps, right? So your water pumps, they could be either submersible, right, or they could be external, or what we call inline. So submersible pumps goes down inside of the water. It make to operate with inside water, underwater, right? So you could use that type of pump to pump your water throughout your system, or there are external water pumps, like what you would typically have for your house, like those your house water pump. You see it outside of the tank, it's not inside of the tank, right? So those you can put outside the tank and connect to the tank, and then it will pump the water throughout the system, right? You can send it to other components. So one pump you can put inside the tank, one you can put outside the tank. Submersible versus external. Another equipment that we typically use, things like light. So like if we set up an aquaculture system, we might want to put in lighting, we might want to have a backup source of power, generator, automatic feeders, computerized water quality monitoring equipment, etc. Yeah. So these are some other pieces of equipment, but it's not equipment that really makes up a recirculating type system. So remember, so really major component like fish tank, for fish growth, your mechanical filter, your biological filter, your air pump, your water pump. Yeah. So other than that, these are other things they will come in contact with if you set up a facility, your lighting, backup power, automatic feeders, water quality monitoring equipment, etc. And these are just an example of what a generator will look like. So in case in case power goes, you would have water continuously flowing through your system, because if water does not flow throughout your system, what will happen to your solid waste and take a build up within your system? So that's why you want to make sure you have a power backup source of power, so you will keep your water pumps working. And most importantly, your air pump or your air blower will continuously be working as well, because again, if power goes and water stops flowing throughout your system and you stop getting aeration, then the fish wouldn't get any dissolved oxygen, and they could suffer from a lack of dissolved oxygen and die. Yeah. So again, having a backup source of power is also important as well, right? Never mind that, we will cover that, right? So some potential pitfalls that you can have within a recirculating system: disease, capital for upkeep and maintenance, right? Like sometimes you have no returns until harvest and marketing, right? So these are some minor little things you want to consider, right? Demand for live product may change, but these are just some variables that could affect your operation, but this really doesn't have anything to do with what we just covered. So again, so that's the idea with respect to the first part of this lecture, which is tank culture versus pond culture, right? So we would have gone through different components that constitutes a recirculating type aquaculture system. We would have seen the importance, the functions, the order in which they are situated within a setup, right? So yes, we would have basically now a general understanding of our recirculating type system is set up and operated, right? Again, while we go along, we will go into different aspects now, like water quality maintenance, water quality aspect. So we'd actually see further how the different components affect water quality parameters, etc. Yeah. So again, that's basically the lecture for today. Do we have any questions on what was covered?
I have no questions, but no, I have a question, but not related to the lecture. I just want to know, like, when you'll be able to, like, post slides and things.
Okay, good. I hopefully should be able to post slides on my learning by this week, right? But other than that, I will start to email out stuff by the early part of this week as well, for the last two lectures that we covered, as well as this one. So you will start to get materials this week, definitely. Yeah. So I'm new to this class. I tried emailing as I was advised by Dr. Mott. I didn't get through. Okay, no problem, Nabila. We will make up. Well, I will probably chat with you outside the class, so we could basically just arrange so you can catch up back on all the lectures and stuff that, or what we would have missed so far. So don't worry yourself about that. So yeah, so we'll talk a little bit outside our class to make up and stuff, and I'll add you into the listing and everything like that for everything else. Yeah. Any other questions? The chat. Yeah. Yeah. So we'll talk a little bit more. Any other questions on anything else pertaining to what we covered, or just anything in general about class? Okay, good. I'll also get a WhatsApp group up and running, so we'll basically be able to chat via WhatsApp for anybody who has any questions or anything like that. Let's see if another question here. Okay, great. Right. So other than that, Nabila, I would probably need your contact information as well to put onto the WhatsApp group, right? So could you send me your contact information, please? You could probably email it. Um, you could also use this email address. Right? So you could use, sorry, I think I direct. All right, no problem. So I'll just take your info now. Right? So if anybody have any other questions or anything like that, then yeah, so thanks for everybody for attending class today. If you have any questions and stuff, we could always chat about it again when the WhatsApp group up, or just save it for when we meet in class next week. Yeah. Again, I'm trying to put together some videos and stuff that we could use, so you'll get a more practical experience how systems and stuff are designed and laid out and different components and things. But once we cover a little more material, you have a better understanding when I do those videos. So yeah, so you all have a, okay, great. Thanks, Nabila. So you all have a good night, and we will pick up next week. Yeah.